eyes could see all forms of radiation, it would be such a sensory overload we probably couldn't handle it. Although there are creatures that see other frequencies besides visible light. Some butterflies have two kinds of coloration, one that we can see, another that only their prospective mates can see. When some male butterflies are examined under ultraviolet light, a different set of colors suddenly appears. This is how the females, here at the bottom of the picture, find their mates. Their eyes can see ultraviolet radiation. By designing technology that generates and receives specific types of radiation, we can use it as a convenient and very powerful tool. As carriers of information, electromagnetic waves pose an interesting puzzle for engineers. Lower frequency waves can pass through the atmosphere undisturbed, which is why radio waves are so popular. But the higher the frequency of the wave, the more information it can carry. So there's been a trend toward microwave communication to carry television and data transmissions. Communicating on even higher frequencies, like light, would be better still, especially for computer links that carry thousands of messages simultaneously. But light does not pass through the atmosphere easily. Dust and water vapor get in the way. A solution to the problem is to pipe the light down extremely clear and extremely thin glass fibers, each about the size of a human hair. Already at work in some telephone networks, fiber optics are replacing copper wire. This is the high-information electromagnetic medium of the future. Radiation is a part of everyday life. Simply walking down the street exposes you to sunlight and virtually every form of electromagnetic radiation, as well as the natural radioactivity of stone, bricks, and concrete. Flying in a jet aircraft gives you a dose of cosmic radiation. 10 trips across the country gives you the equivalent dose of 1 dental X-ray. There's even natural radioactivity in the food we eat. These exposures are all part of the natural environment. The danger in radiation is that we've learned how to concentrate it into lethal doses. These concentrations are put to useful work, like generating electricity, but their intensity makes them extremely hazardous. Plus, there's the added problem of disposing of radioactive waste products. All forms of radiation need to be handled with safety in mind, from simple sunglasses on the beach to protective goggles in the workplace. Microwaves can cook your food, they can also cook your brain. So safety around microwave transmitters is of vital importance. Nuclear radiation has varying degrees of health hazard, depending on the amount. Alpha and beta particles can damage living cells. They don't penetrate the skin from the outside very easily, but they can do damage when they're inhaled or ingested. Gamma rays are very dangerous because they do penetrate, and they have an effect on DNA molecules, our genetic code. It was this effect that fueled the science fiction stories of giant creatures. And the residents of Hiroshima felt it firsthand. It is because of the concerns for safety that extensive testing is performed on containers used in the transport of radioactive materials. Experimenters have gone to great lengths and to great destruction to prove that the containers will not leak if an accident should occur. The best approach with radiation is the cautious approach. Treat all radiation with respect and keep your distance. When you're near radiation, know the type and its intensity. We usually think of radiation as a carrier of energy, but it can also be a carrier of vehicles, an idea that's been proposed for the space program. Electromagnetic radiation, like light, actually exerts a pressure. The pressure is extremely small, but it's measurable. If a light material, such as a thin plastic, was several kilometers square, the pressure could move it. if it were in the vacuum of space. Such a vessel, named the solar sail, could be built. Once unfurled like a giant flower, sunlight would literally push the vehicle to the moon or other planets. It would take a little longer to get up to speed, but that doesn't matter. It runs on free energy. Another design for the solar sail is called the solar heliogyro, a spinning propeller with each blade the length of 3 football fields. It would be large enough to be seen from the ground, silently drifting on a sunbeam across the ocean of space. This program was produced under the direction of AIT at the facilities of Telemation Productions and is part of Principles of Technology, developed by the Agency for Instructional Technology in cooperation with the Center for Occupational Research and Development and in association with a consortium of state and provincial vocation education agencies, together serving education.